So today we're going to talk about kinetic energy. This is energy due to motion. One way I put it is it's the energy of movement. Anytime you see something moving, it's going to be displaying kinetic energy. A baseball being hit by a baseball bat is an example of kinetic energy. A skateboard moving is an example of kinetic energy. Then we have the mass and kinetic energy. Now, mass affects kinetic energy in a great way. As mass goes up, so does kinetic energy. More mass means more energy of movement. So the greater the mass, the more ability something has to gain kinetic energy. To demonstrate mass and kinetic energy, I'm going to take two objects. One, a small tennis ball, which is going to have a smaller mass, and a baseball, which is going to have a larger mass. And I am going to drop them at this cup here that is covered with aluminum foil, and you will see the effect of how much kinetic energy goes into the aluminum foil. The reason why we can do this by dropping it, and hopefully you remember, is what is constant when something is falling towards the earth? Gravitational acceleration. Remember, it's always the same. So the only thing that's going to be changed between these two objects is their mass. Okay, so now I will demonstrate the tennis ball and its effect on the aluminum foil. Okay, as you can see, it did definitely make it a dent there. Okay, so I'm going to go ahead and I'm going to straighten this out again, and we're going to see from the same height the baseball and its effect on the aluminum foil. And then we have speed and kinetic energy. So as speed increases, so does kinetic energy. In fact, the kinetic energy is squared compared to the speed or velocity of an object. So as the kinetic energy goes up, as the speed goes up, the kinetic energy goes up by a square of that factor of speed. So it goes up squared. To demonstrate the relationship between speed and kinetic energy, I'm going to kick a soccer ball at this trash can. Now, if I kick it with a small amount of speed, the kinetic energy is not going to be enough to cause it to tip over. However, if I kick it with a large amount of speed, the kinetic energy will then topple over the trash can. Potential energy. So we just talked about kinetic energy. Now we're going to talk about potential energy. So potential energy is the energy due to interactions between objects, or we can call this stored energy. This is the energy that something has because it is positioned in a way where it's gaining energy, or has the ability to gain energy, but hasn't yet done it. I have a skateboard here on a slope. Does the skateboard have energy right now? If you said yes, you'd be correct. It does have energy. It has stored energy currently because it's sitting on a slope. The only thing that's preventing this skateboard from moving is this rock here. So, if it has the potential to move, what do you think will happen if I pull the rock away? Let's see. It moved because there was potential prior to me releasing the rock. There are two forms of potential energy. We have elastic energy, and then we have gravitational potential energy. So we have elastic potential energy and gravitational potential energy. First, we're going to talk about elastic potential energy, which is energy when something is compressed, compressed like squished or just brought together. Squished is a better way to understand it, like compressing something is squishing it together. Or stretched like a rubber band. So all of you have seen a rubber band, you know that a rubber band stretches. When you're stretching it, if you were to let go, what's going to happen? The rubber band's going to move because it has the elastic potential energy before you let it go, and then once you let it go, it becomes kinetic energy, but we're not really talking about that right yet. To demonstrate elastic potential energy, here I have a spring in between these pruners here, and as you can see, when I squeeze it, I'm compressing the spring. It is causing elastic potential energy. Now if I were to let it go, it springs open. Another form of elastic potential energy is when you draw the bow. When you draw on a bow, right, you are creating potential energy here. And I'm pulling on this, so I am creating potential energy. Now, the bow is going to do nothing unless I let it go. Once I let it go, it springs forward with kinetic energy. But before it moves, it's got the potential energy. So it has the potential to go forward. And it did. And lastly, we're going to talk about gravitational potential energy. Now, gravitational potential energy is stored energy due to a gravitational energy field. This is anytime something has energy because it's being acted upon by gravity. So if gravity is going to cause something to move, but it's not moving, such as a great example of this is the apple from the tree, Isaac Newton, right? The apple had gravitational potential energy, and then eventually it fell from the tree, went going straight to the earth because gravity pulls everything to the center of the earth. Right, to demonstrate gravitational potential energy, I have a ball tied to a string. Now, as I'm holding this, what is pulling the ball down? The gravity, right? The Earth's gravitational field is pulling the ball towards the Earth, and I can feel it in my hand, but because I'm holding it, the ball is going nowhere. It's not going the way it wants to, which is down. So, we have the gravitational potential energy. The ball is being pulled towards the Earth. What do you think is going to happen once I cut the string? Which way will the ball go? If there were no ground, where would the ball go? So you should have said to the center of the earth because that's where the ball wants to go. So let's go ahead and let's take a shot and see what happens here. So that concludes kinetic and potential energy. Remember, kinetic energy is anytime something's moving, and potential energy is the energy something has because of its position, such as a roller coaster cart at the top of a roller coaster. Thank you for watching, and I hope this helped you out.